Using a bare conductor in non-metallic sheath cable as the grounded or neutral conductor in a residential circuit, where the ground and neutral bar are one in the panel, presents several technical hazards. While it might seem to work in some situations, such as the split yoke receptacle scenario described, it introduces significant risks and violates established electrical codes. A primary concern is ground fault circuit interrupter, or GFCI, misoperation. In a properly bonded system, the neutral and grounding conductors serve distinct roles in carrying return currents. A GFCI operates by monitoring the current balance between the hot and neutral conductors. If the bare conductor is used as a neutral, a ground fault current may not flow through the GFCI. This renders the GFCI ineffective in detecting ground faults, which can lead to electrical shocks or fires. The GFCI relies on the imbalance of current to trip and cut off the power, protecting people from dangerous electrical conditions. By misusing the bare conductor as a neutral, the intended safety mechanism is bypassed. Improper grounding is another critical issue. The bare conductor is specifically designed and intended for grounding purposes only. It is meant to provide a low impedance path for fault currents to return to the source, allowing overcurrent protection devices, such as circuit breakers or fuses, to trip and clear the fault. Using the bare conductor as a neutral compromises the integrity of the grounding system. This can potentially allow fault currents to flow through unintended paths, such as metal enclosures, water pipes, or other conductive materials. If someone were to come into contact with these energized objects, they could receive a severe electrical shock. The grounding system's primary function is to provide a safe path for fault currents, and repurposing the bare conductor undermines this critical safety feature. Fire hazards also arise from using the bare conductor as a neutral. One key concern is overheating. The bare conductor typically has a higher resistance than the insulated neutral conductor specified for the circuit. When used as a neutral, it will generate more heat due to the higher current flow through its increased resistance. This excessive heat can lead to the deterioration of the surrounding insulation on other conductors, increasing the risk of short circuits and ground faults. In severe cases, the overheating can ignite nearby flammable materials, resulting in a fire. Arcing is another potential fire hazard. If the bare conductor, when used as a neutral, comes into contact with other conductive materials such as metal boxes, pipes, or even other wires, it can create arcing. Arcing is a phenomenon where electrical current jumps across a gap, generating intense heat and sparks. These sparks can easily ignite nearby flammable materials, causing a fire. The risk of arcing is heightened when a bare conductor is used as a neutral because it is more likely to come into contact with other conductive surfaces. Beyond fire and shock hazards, using the bare conductor as a neutral can also lead to damage to sensitive electronic equipment. Neutral conductors are essential for completing electrical circuits and providing a stable reference point for voltage. If the bare conductor is used as a neutral, it can introduce noise or interference into the circuit. This noise can disrupt the operation of electronic devices connected to the circuit, potentially causing them to malfunction or even be permanently damaged. Electronic devices are designed to operate within specific voltage and current parameters, and the introduction of noise can push them beyond these limits. Electrostatic discharge, or ESD, is another potential hazard. Bare conductors can accumulate electrostatic charges due to friction or induction. If a person touches the bare conductor, they can receive an electrostatic discharge. While ESD is not typically life-threatening, it can be painful and, in some cases, can startle someone, leading to an accident. In environments where sensitive electronic components are present, ESD can also damage these components. Corrosion is a long-term concern. Bare conductors are more susceptible to corrosion than insulated conductors. Corrosion increases the resistance of the conductor, which further exacerbates the overheating problem. Over time, corrosion can degrade the conductor's ability to carry current safely, leading to potential failures and hazardous conditions. The increased resistance due to corrosion reduces the effectiveness of the neutral path, potentially causing voltage drops and further stressing the electrical system. Moreover, using bare conductors as neutrals is a direct violation of electrical codes and industry standards. These codes are in place to ensure the safety and reliability of electrical installations. Violating these codes can result in failed inspections, which can delay or halt construction projects. Furthermore, it can create potential insurance issues. If a fire or electrical incident occurs as a result of using the bare conductor improperly, the insurance company may deny coverage due to the code violation. Electricians have a professional and ethical responsibility to adhere to electrical codes and ensure that all electrical installations are safe and code compliant. Using bare conductors as neutrals is a clear breach of this responsibility. It demonstrates a lack of understanding of basic electrical safety principles and can have serious consequences for the safety of building occupants. When troubleshooting electrical problems, it is essential to identify and correct any instances where the bare conductor is being used as a neutral. The correct solution is to install the appropriate wiring, such as a 14/3 cable, to provide separate hot, neutral, and ground conductors. In situations where it is difficult to run new wiring, alternative solutions may include using a GFCI circuit breaker or adding a separate ground wire. However, these solutions should be carefully evaluated to ensure that they meet all applicable codes and safety standards. Ultimately, electrical safety is paramount, and any shortcuts or compromises that could jeopardize the safety of people or property should be avoided. Understanding the technical reasons why certain practices are unsafe is crucial for making informed decisions and ensuring the integrity of electrical installations. Firstly, GFCI misoperation occurs when the bare conductor is used as a neutral, preventing the GFCI from detecting ground faults. Secondly, improper grounding compromises the grounding system, potentially allowing fault currents to flow through dangerous paths. Thirdly, overheating of the bare conductor due to higher resistance can lead to insulation damage and fire. Fourthly, arcing can occur if the bare conductor comes into contact with other conductive materials, igniting nearby flammable materials. Fifthly, damage to electronics can result from noise or interference introduced into the circuit. Sixthly, electrostatic discharge can occur when a person touches the bare conductor. Seventhly, corrosion of the bare conductor can increase its resistance and degrade its ability to carry current. Eighthly, code violations can result in failed inspections and potential insurance issues.